Welcome to the GF Series infrared camera tutorial from the Infrared Training Center. This orientation will provide you with an overview of how to operate this line of thermal imagers from FLIR Systems. Of course, knowing how to use this camera is just the first step. Thermographers must also understand how to interpret what they're seeing, the environmental conditions needed for a successful inspection, and what factors might impact the accuracy of their recorded data. For that to happen, however, proper certification training is required. So to get the most out of your investment in this technology, ITC can help. Head to infraredtraining.com/schedule where you'll find a number of upcoming IR training dates available at convenient locations across the US and Canada. And for our fellow thermographers based in Europe, the Middle East or Africa, irtraining.eu has the latest schedule for classes in your region. Regardless of your location, if you're ready to get certified, stay tuned until the end of this video for more information, including how to learn about special offers that may be available for certification training. Most of the cameras in this line of thermal imaging systems are designed for gas detection, the exception being the GF309, which is used for furnace and high temperature inspections. As such, while they may look similar, there are some important differences in the technical specifications and capabilities for each one that you should understand. These can be found on the FLIR support website at support.flir.com. Once on the site, navigate to Downloads and click on Datasheets and Field of View Calculators. This will display a matrix containing all of FLIR's thermography products. Selecting the model will bring you to a list of the various camera configurations for the GF series. Pick the one for your imager's configuration and click on the corresponding datasheet to view the camera specifications. Now before we go any further, let's first see what comes in the camera case, as well as learn more about the FLIR support website and its many resources. For that, here's ITC's Jason Gagnon.
Included with the camera are all the essential components and accessories required to get you up and running with your new thermal imager as quickly as possible. This segment will orient you with the basics of unpacking your camera, including an overview of battery charging, what accessories are in the case, plus how to register your new camera. Now the first thing you'll want to do is charge your new batteries. We recommend charging them for about 3 hours before their first use. Here's a battery charger that comes with the camera, and you'll find the power supply for the charger in the accessories box. The lights on the battery will blink while they're charging and turn solid once fully charged and ready for use. Also inside the case, you'll find some documentation for the camera, a USB cable, an HDMI cable, and an SD card for storing images. The documentation includes a QuickStart guide and a calibration certificate. It's always a good idea to register your camera as soon as possible. Registration will typically extend the warranty of the thermal imager. The GFX cameras must be registered in order to create the unlock code that is required to use the camera. Registration can be done at our FLIR Support Center website. To access the page, go to support.flir.com. Select Product Registration to sign up for a new account, or click Log in the upper right corner if you already have an account. Once you're logged in, click here to validate your camera's serial number, which can be found either on the calibration certificate or on the camera housing inside the battery compartment. Support Center is also where you can download the FLIR software, such as FLIR Tools and Thermal Studio. The software can be used for analyzing thermal images, videos, and for creating inspection reports. To download any of the products, click Software and SDKs from the home page. From the product list, select Temperature Analysis Software. Then, from the next menu, choose the product you wish to download. Most products have an EXE installer, which can be easily run from the web page. Some products, such as Tools Plus and Thermal Studio, require license activation. The license key may be included on a scratch card in your camera case. You can also order a license online at FLIR.com. If you have any product support questions, please click Ask a Question from the home page, and our support staff would be happy to assist. All image and video files are stored on a removable SD card that comes with the thermal imager. The slot for the SD card is located on the back of the camera under this cover. Now it's important to note that this series of thermal imager does not have any internal memory, so be sure to install the card right away as it's needed to store data. A good tip is to always check that you have the card inserted prior to an inspection. On the back of the camera, you also find the USB port, which is used for downloading images to the PC and streaming video to our PC software, such as FLIR Tools Plus and Researcher. You'll also find an HDMI port for streaming video to a TV or projector. Once the batteries are charged, go ahead and install one and power up the camera. The GF series cameras use a mechanical cooler in order to cool the infrared detector so it can display an image. The cool down process typically takes around 7 to 10 minutes. Once it reaches the cool down temperature, you'll hear the motor slow down and it will begin to display an image. Because they are ATEX certified, the GFX cameras will prompt you to enter an unlock code before they can be operated. This code is sent to you by email once the camera has been registered at support.flir.com. If you have any trouble finding the code, please contact our support staff for assistance. Okay, now that the imager is up and running, batteries are charged, and the SD card is installed, let's take a closer look next at some of the important features and functions of your thermal imager.
Before we get to the camera's basic functions, I wanted to point out another great resource for thermographers, and that's the ITC website at infraredtraining.com. Besides our latest training schedule for the US and Canada, you'll find a number of free tutorials, including an overview of the software that Jason had mentioned here a moment ago. Also, there are at least 2 webinars on optical gas imaging you might find useful as well. All are listed under our on-demand tutorials, which feature about 24 topics in total, all free, and can be accessed anytime at infraredtraining.com/webinars. So now that we've covered what's in the case, let's talk about the basics of operation for the FLIR GF series camera. First, we'll review the mode wheel. That's this dial here on the left side of the camera. The mode wheel is where you switch the operating modes of the thermal imager by turning the dial. These include camera for live imaging and capturing still photos, video for recording video clips and sequences, archive for playback of saved images, video clips and sequences, program to set up periodic saving of images, and setup to change the general settings of the camera, and this includes things such as date and time, video recording format, display brightness, and more. Now it's important to note that some GF series thermal imagers have a quantification mode in place of program. And this feature works in conjunction with the QL320 tablet from Providence Photonics. This optional hardware allows you to quantify gas leaks from video sequences recorded while using this mode. It comes standard on the GF620 series thermal imager, but can be added to other GF cameras with a software update. For those of you with thermal imagers that only have program mode, you can still use this feature to record video sequences that are time delayed. Having the correct date and time entered into your camera is important for proper documentation and record keeping. These values are tied to each data file when you save a thermal image and cannot be changed after saving. To set the date and time, turn the mode wheel to Setup. Here you'll see 4 tabs displayed at the top, the first of which is the Regional Settings submenu. Use the joystick to navigate to Set Date and Time, and push the joystick in to select this field. A display will appear on the right with values for both date and time that you can adjust individually. Move the joystick up or down to highlight the desired field, and then press the joystick in to select. Moving the joystick up and down will now change the entered value. When set, press the Menu Back button located to the right of the joystick to back out of this display and return to the Regional Settings menu. Now it's here that you can also set things like date and time format, as well as the temperature and distance units for the thermal imager. And to return to live imaging mode, turn the mode wheel all the way back to camera. Now the range covers an interval of temperatures that the detector is able to accurately measure without going into saturation. You work within a range, and when saving an image, all of the temperature data in that particular range is captured. Now, the GF series thermal imager is set up a little bit differently from your standard handheld thermography camera in that it has 9 smaller temperature ranges built into it, and they're divided up between -4 to 662 Fahrenheit or -20 to 350 Celsius. Now, what you do is choose a suitable range for your target and environment, and then work within that range, adjusting the span and level as necessary to get the best thermal contrast. We'll have more on that here in a moment. The easiest way to change the range is to press the thermometer button here on top of the camera. Doing so selects your current range. You can then toggle between ranges using the joystick, moving up or down. As with range, focus is another adjustment that must be made correctly before saving. You cannot change the clarity of the focus once you've captured a thermal image. Proper focus is also essential when using this camera to detect gas leaks, as these subtle thermal patterns are tough to spot, especially when your image is soft and out of focus. And depending on the model, there are a couple different ways to adjust focus on this series of camera. For some, manually rotate the focus ring here. This is on the lens housing on the front of the camera. You do that until the proper focus is obtained. For other cameras, such as the GF320, there's an autofocus available by moving the slider here on the hand grip. And it's important to note that using the viewfinder, you should adjust the diopter as well. This is the small focus control which you see here, which adjusts the clarity of the screen on the inside. Thermal tuning, or adjusting thermal contrast, is the process of changing the temperature scale in the camera, what's known as modifying span and level in our certification classes. Adjusting the scale changes the contrast and brightness of the thermal image. This allows you to highlight important areas of thermal detail, and in this case, with these cameras, it enhances your ability to detect gas leaks. Now, on the GF series thermal imager, there are 3 options to adjust thermal contrast. These are auto, manual, and HSM, or high sensitivity mode. To make these adjustments, press the AM button located here next to the Save button on the control panel. This allows you to toggle between the 3 imaging modes. By default, the camera is set to automatic adjustment mode. This will automatically set the scale based on the hottest and coldest objects in the frame. That's nice for quick adjustments, but not something you want to use when targets are surrounded by either very hot or cold objects. This might cause you to miss some leaks. Selecting manual will allow you to customize the scale settings. In manual mode, you'll see that the scale numbers will highlight. Push the joystick left or right to adjust the span or width of the scale. Pushing left moves the numbers closer together, narrowing the span and increasing thermal contrast. Pushing right moves the values further apart, increasing the size of the scale and decreasing thermal contrast. Moving the joystick up or down changes the level, which is similar to adjusting brightness. The third option is high sensitivity mode. HSM mode increases the camera's detectability by about 5 times using image subtraction to find subtle thermal changes between frames. The contrast of this feature can be changed by moving the joystick left and right while in HSM mode to help you better identify these changes. Sometimes the only way to see leaks, or those in highly congested areas such as pipe racks, is to use HSM mode. This camera series also offers a number of different color palettes to help with contrast. And it's possible that one palette may work better than another in certain imaging situations. Now, I've spoken with our other instructors, and the consensus for this particular camera is that it's best to use the programmable button here on the top of the camera. Now, to set this button, you're going to change the mode wheel all the way back over to Setup. And using the joystick, navigate to Preferences and select the programmable button option. Here you'll see several options, including one to invert the palette and hide and show graphics. If it's not done so already, highlight the next image palette and press on the joystick to select. Now back in live imaging mode, you can toggle through the various color palettes by simply pressing this P button on top. If you ever need to measure the temperature of a surface, this GF series camera, with the exception of the GF300, offers several temperature measurement tools. To access these, press the menu back button here and navigate over to the Edit tab. Here you'll find a temperature spot meter, an area box for recording maximum, minimum, and average temperatures, a delta T function for evaluating temperature differences, and a line profile to analyze temperature variations across a linear path. For now, we'll just use the spot option here. Pressing on the joystick will put a spot temperature on the screen and the value in the upper left-hand corner. Use the joystick now to move the spot around and measure temperatures in various regions of the image. And as always, with a FLIR thermal imager, these and other tools can be accessed and modified in either a saved image or the reporting software. Oh, and one more thing to mention, if you're using a measurement tool, you also need to adjust the object parameters. These include the values for emissivity, reflected temperature, relative humidity, air temperature, and atmospheric distance. All 5 parameters affect temperature measurement accuracy, especially emissivity and reflected temperature. As such, these values must be set correctly, and to know what the numbers are requires a Level 1 IR certification training at a minimum. To save a single thermal image with this series of camera, press the gray Save button located right above the joystick, marked with the letter S. This is while you're in camera mode. It will pause the image and bring up a preview menu. You'll see it there on the right-hand side of the screen. To save the image now, select the disk icon and push in on the joystick. You can also back out of saving by selecting Discard, modify the digital photo, make adjustments to the frozen image, or edit the temperature measurement values before saving. Now, since gas detection is likely the primary use for most cameras in this series of imager, capturing video of the leak is usually the preferred way to collect data. Video allows you to see gas movement more easily and better represents the nature and extent of the problem, something a still photo can't convey. To record a video, turn the mode wheel to video. Pressing the Save button will now start a recording. You'll see this indicated by the timer located in the upper right-hand corner of the screen. To stop recording, press the Save button once again. As with still images, a preview menu will display where you can save the video, discard it, play the recording back, pause, or even skip to an individual frame. All the detector elements can respond a bit differently to incoming infrared energy. Also, heat generated by the camera or that from the surrounding environment can influence this response as well. This will cause areas of the image to appear artificially warmer or cooler, creating non-uniformity in the displayed data. The non-uniformity correction helps adjust for this by normalizing each pixel against a uniform target. On the GF series cameras, this non-uniformity correction is a manual process. It can be initiated by holding down the auto manual button here on the hand grip. Now, before you do that, be sure to first put the lens cap in place so that the camera has a uniform target to observe. If you forget to cover the lens, the camera will compensate against whatever scene you're looking at, effectively imprinting that image into the detector, causing it to appear as if it's been burned into the image. Now, not to worry, this is only temporary. By putting the lens cover in place and running the calibration again, you can remove this mistake and return to live imaging mode with a balanced and stable detector array. It's recommended on the GF series camera that you run this process at startup, after every temperature range change, whenever you experience a large ambient temperature change, or every couple of hours of operation. All right, now that we've covered the basics, what's the next step? Well, if you haven't done so already, it's time to get certified. For those of you in the US and Canada, head to infraredtraining.com/schedule to browse upcoming training dates and locations. And if you're based in Europe, the Middle East, or Africa, irtraining.eu is where you'll find a list of training classes in your region. And if you're thinking about attending a training class here in the US, we also run a number of special offers throughout the year. To hear what those are and check availability, call us at the number below or email ITC at info@infraredtraining.com. Also, for those programs with 6 or more thermographers who need certification training, an on-site course is likely your best bet. Not only will you save money by having ITC come right to your facility, we can also provide customized training that utilizes your equipment and infrastructure too. Contact us to learn more and get a quote. And if you've already registered for a certification class, well, we look forward to working with you. Thanks for watching, and we'll see you soon.